Okay, the second theorem I'm going to call the secant segments theorem because it has to do with secants and treating them as segments. So let's look at this. A lot of words, we'll try to make sense of it. Secant segments theorem. If two secant segments are drawn to a circle from an exterior point, okay, we start those secants at the same point exterior on the outside of that circle. Then the product of the measures of one secant segment and its external secant segment equals the product of the measures of the other secant segment and its external secant segment. Wow, a lot of words. What does it mean? Well, a secant segment, the product means the result of multiplication. Measure, that's a number of one secant segment. In other words, the whole segment and its external secant segment. In other words, whatever is outside of the circle equals the product of the number, in other words, multiplication result of the number that represents the other total secant segment and its external segment. Well, let's draw a picture. We have a circle. We have an exterior point A. We have secant AC that is drawn through the circle, okay, and it goes through one part of the circle at B and ends on the circle at C. We have another secant that starts at A, the same point A. It goes through the same circle at E, and it ends on the circle at D. Okay? You understand what we have? Two secants. They intersect that circle at 2 points. Each one does, at 2 different points. They just happen to all originate and start at the same point and intersect outside. We talked about exterior intersections on the last one when we talked about calculating arcs and angles. So, let's look at this, make sense of it. It says the product of the multiplication result of the entire secant segment, AC, times its exterior portion, AB. So we're going to take the whole thing, the length of the whole thing, AC, and multiply it times its exterior portion only. Okay, that's all we're interested in. And that is going to equal the entire length of the other secant segment, AD, times its exterior portion. So AC times AB is going to equal AD times AE. Okay? AD times AE. All right? That's the secant segments theorem. All right, the last theorem we want to look at, I call it the tangent and secant segment theorem. This has to do with tangents and secants. A lot of words, we'll try to make some sense of it. If a tangent segment and a secant segment are drawn to a circle, again from an exterior point, in other words, they originate from an exterior point outside the circle, then the square of the measure of the tangent segment. In other words, if we multiply the tangent segment by itself, okay, square it, it equals to the product of the measures of the secant segment and its external secant segment. Okay, we were introduced to that last time. One more time, if a tangent segment AB, and a secant segment are drawn to a circle, and a secant segment, AC, from an exterior point, and they all both originate from point A, which is exterior to the circle. We have a tangent AB to that circle. We have a secant AC to that circle, crosses 2 places, crosses at D, ends on the circle at C. Then the square of the measure, multiply AB times itself, AB times AB, or AB squared, equals to the product of the measures of the secant segment, AC, and its external secant segment, AD. So AB times AB equals AC times AD, or AB squared equals AC times AD. Okay? Square the tangent portion, then multiply the entire secant segment by its external portion, and they are equal to each other. Put these up in a little table so you can see them compared to each other, and then we'll do some samples. Okay, now here's just a summary of them. You see the three of them together, see how they're similar and how they're different. Okay, intersecting chords. Intersecting chords are going to intersect the interior of the circle. Okay? We're going to take those pieces of those chords, we're going to multiply them by each other, and they're going to equal each other. The pieces of A, B, we're going to multiply together, and they're going to equal the pieces of DC that we multiply together. All right? Now we come over here to the secant segments, and they originate externally to it and come across, and the entire secant AC times its external portion is going to be equal to the entire secant AD times its external portion. Okay? Looking at multiplying the external portions. Notice that we're not involved with the internal portions except as the whole secant. Then we have the tangent secant segment. Okay, segments. And on this one, the tangent, we square it. It's sort of like doing this here, okay? We got two things here. We got to have two things for that. What do? We just take that one. Multiply it, okay? Because it's tangent, we just multiply it by itself. Either this or this equals the entire secant times its external portion, okay? Gives you an idea of what they look like and how they compare with each other all on the same sheet of paper there, so to speak. Look at them. Do some samples, and we'll be done with this